Okay, fellas, so hopefully you completed your homework correctly, and your homework looks something like this, where I asked you to find a 30, 60, 90 triangle. So some of you either wrote it with x radical 3, and then 2x, or some people wrote it with 3 radical 3, and then 6. Right, so there's a couple different ones. I would like us to, it's just a ratio, so when you find values, it's going to simplify anyway. So I say 1 radical 3, and 2, where the 1 is across from the 30, the radical 3 is across from the 60, and then the 2 is across from the right angle. And then same for 45, 45, 90. 45 is 1, 45 is 1, and across from the 90 is radical 2 for 45, 45, 90. Some people wrote 2, 2, 2 radical 2, or x radical 2. That's all fine, but this is how we'll memorize it for our trig functions down here. On a regular 30, 60, 90 triangle, sine of 30 is 1/2, cosine is radical 3 over 2, and tangent is 1 over radical 3. And these will memorize. You will memorize for a quiz next week sometime. 60 is, sine of 60 is radical 3 over 2, cosine is 1/2, and then tangent is radical 3 over 2, radical 3 over 1. So obviously these are flips of each other, which makes sense. And then these are opposite. So as sine goes from 30 to 60, cosine goes from 60 to 30, right? It's the same numbers. Okay, here's 45, 45, 90, 1 over radical 2 from either angle, whatever you look at it, 1 over radical 2 for sine, 1 over radical 2 for cosine. It's all the same. This is where they overlap, as we saw. And then tangent is 1 over 1. We talked about that one in class. Okay. Here is the sine curve, and what I wanted was the first 1, 2, 3, 4, 5 dots clicked, so the 0, 0, and then the next 4. And you see it says pi over 2, pi, 3 pi over 2, and 2 pi. Why is it doing that? Where's the degrees? Well, as we mentioned, radians are more important for us because it matches the units of the input to the output. So Desmos says, well, this is preferable. 30 degrees doesn't really mean much. We want input to match output on a function, so it does it in radians. Eventually, we'll get to the point where we know all these radian measures by heart as well. So we're going to have to memorize these, and then radians, so eventually you'll be able to say sine of pi over 2 is equal to, and you should eventually know what that is. Okay? That's, and they're all degree measures, 90, whatever. Okay, cosine. It's very, very similar if we kind of look at them side by side. Sine goes 0, 1, 0, negative 1, 0. So it starts flat, up, middle, down, middle. 0, 1, 0, negative 1, 0. Cosine, as we saw, is almost exactly the same, just like a little bit off, a little bit shifted from like top down. 1, 0, negative 1, 0, 1. So cosine is this, sine is that. Up, down, up. This one is down, up. Okay, but the numbers are the same. Here's a pi over 2, here's a pi, here's a 3 pi, here's a 2 pi. And eventually we'll know it's 90, 180, 270, 360. I graphed tangent. I didn't ask you to. We're just taking a look at tangent. I wrote down where the pi over 2 and pi and all this stuff comes in. 0, pi, 2 pi. How come this says pi over 2 and 3 pi over 2? Well, those are right here, but if we look at them side by side, because we know that sine over cosine is equal to tangent, as I mentioned in some of my classes, whenever cosine hits 0, sine divided by 0, that can't happen. Pi over 2. Here is an asymptote in tangent because cosine is 0 at pi over 2 or 90. 3 pi over 2, cosine is 0. There's another asymptote. Okay, and I put these in blue to kind of help show that's because of cosine. But, if you can, here's the graph. You could screenshot that from the thing and from the video and just pop it in your notes. But it's just kind of a general rule or a general fact about tangent. So, our graph, we don't always use that. We mostly use these two. That's why I wanted these two. But this is why it looks like that. And hopefully we start to piece all this together. Okay, so I wanted you to find arc length of a circle. Some people found it with another formula that looks something like S theta or r, right? S theta r, or something like that. So that's the equation using theta as radians, and it probably says from the Google search, it's the first thing that comes up, that's the one it gives you, and it says in parentheses at the bottom, in radians. This is the arc length of a circle in degrees, so if you didn't write the degrees one, please write that down. If you did, great. The other one is necessary later on. But here's arc length of a circle, and that's essentially what radians are. Here we go. Here's our new set of notes. Radians are arc length divided by radius. And as I said, kind of the reason being is if I have a circle, if I have a real circle, and then I have a radius like this, and I think in one of the classes I mentioned this, if I want to know how much of the circle is being used, what portion of the circle, to use the words I said the other day, is being used right here, you would say, well, a quarter of the circle, or 25% of the circle, is being used. If I make this circle and I make it larger, still 25% of the circle is being used. If I make it smaller, still 25% of the circle is being used or being colored in, but the radius, I guess, like disregarded in that measurement. Same idea where radians, you're saying, well, don't worry about the radius, just compute what the arc length is. Oops, 360. Made it a little clear what the arc length is in regards to the radius, so that you can cancel these out. That's why we use this equation. Okay, so now you have 2 pi theta over 360. 2 pi times theta over 360. Well, 2 and 360 is pi over 180. I'll just put pi theta. Okay, so our equation to find radians, what is radians, is simply using pi over 180. The theta is the angle measure, again. So that's how we go from degrees to radians, would be by multiplying by pi over 180. And that's what the theta is here for. So if I have 60 degrees, how much is that in radians? 60 times pi over 180. That would be in radians, leaving it in terms of pi. Just like with E, leave it in terms of pi. Going from degrees to radians is multiplying by pi over 180. Degrees to radians is multiplying by pi over 180. Okay, so let's try it. 30 degrees. I would multiply by pi over 180. 30 pi over 180. Obviously, this can be simplified. 30 and 180 is 3 over 18, which is 1 over 6. 30 degrees, an important number we need to know. 30 degrees is pi over 6 radians. So you're multiplying by pi over 180. And eventually we'll be able to do this in our head, but it's new. So we can have a bunch of practice with it, and then you'll have eventually a quiz where I ask you to find all these things. Obviously, no calculator. 20 degrees times pi over 180. Now, 20 degrees isn't an important degrees to us, but we still have to know how to do it. 20 degrees times pi over 180. Right? And here's pi over, well, zeros cancel. 2 over 18 is pi over 9. There's my answer. So pi over 9 is 20 degrees. Right? And eventually this will be something we'll memorize. 60 degrees, another important number, times by pi over 180. 60 pi over 180. Well, the zeros cancel out. 6 over 18 is pi over 3. And there's just a couple values. I only did a few because you're going to have a bunch on homework. Okay, so there's your 30 degrees. How do you get it into radians? Times it by pi over 180. And that's because of this right here. Theta pi over 180. That's degrees to radians. If I were to take these values and say, can you go from radians to degrees, that would mean for you, you already have a pi on top. You want to cancel the pi on top, so you're going to multiply by 180 over pi. And that's going from radians to degrees. It's the reciprocal, and how I remember it is if there's a pi on top, I want to multiply it so that there's no pi. Degrees has no pi. To go from radians to degrees, I want no pi. So how do I cancel out a pi? Pi's got to be on the bottom. That's how I remember it. And as you see from our graphs, looks like pi's always on top. So when you're going from degrees to radians, you want the pi on top. Pi on top. When you're going from radians to degrees, we want the pi to go away, so we want a pi down here. And then the 180 is up there, right? Because it's just 180 in pi, but a lot of times we mix up, well, what is it over? So it's 180 over pi when going from radians to degrees, because I don't want the degrees anymore. Okay? So if I multiply these two together, my pi's cancel, obviously, which is what I want. I get 180 over 4, which is, I believe, 45 degrees. 180 divided by 4 is 45 degrees. Okay? Right? And that's just simple work. I guess you could have a simple calculator to do it. 180 divided by 40, 45. Okay, next one. A little bit of a weird pi number, but we see 3 pi over 2 on our cosine sine graph. So let's look at this one. So same thing. I want my radian turned into degrees. I make sure I times it by 180 over pi, so it goes away, and I get 2 times 180 over 3. 2 times 180, well, that's 360 over 3. And then 360 divided by 3, that's an easy number, 120. Okay, so this is what we're looking at now. So that's, you have a bunch of that to start, going from degrees to radians. Okay, and then from radians to degrees. And then, since we know these values, if I were to say sine of 30 is 1/2, if I say sine of, and I put in here, pi over 6, the answer is still 1/2. Just in radians, right? So sine of 30 degrees is 1/2, and also sine of 30 degrees, or pi over 6 radians, is also 1/2. Okay, so we'll start to see some of those next time too, where once you know your famous degree measures for 30, 60, 90, and 45, 45, 90, if I put pi over 6, or a pi over 3, or a pi over 4, because that's 45, you can also get these. Okay, and then the last thing I'll show you is this. So there are things called reciprocal functions. Reciprocal. Okay, where obviously we know what sine, cosine, and tangent is, and they're not basic functions. They're not one of the 12 basic functions. But if I take sine and I flip it over, you get hypotenuse over opposite. And that's obviously, reciprocals are used very often. I mean, we already did a bunch right now. We just took 180 and pi and flipped it already in the first kind of day of trigonometry. So it has a name. It's called cosecant. Cosecant. And that matches with sine. Cosecant. Just like sine and cosine, this is cosecant. Well, what's the reciprocal of cosine, which we'll have to memorize eventually? Well, that is secant. Is that not annoying to have cosine map with secant and then sine maps with cosecant? Yes, it is. Why does it do that? Well, sine and cosine are complementary, so when you reciprocate them, it's like, well, the other one's the complement of the other one. So it does work out mathematically, but of course, when you're memorizing, you're like, well, that's annoying. But again, a lot of this first chapter or first lesson that we're doing is kind of like a bunch of stuff from chapter 4. These are things that are worth memorizing, and I'm going to give you a quiz on them soon so we can really make sure we know what these things are. Tangent, pretty easy. Cotangent, nice cotangent. And that is adjacent over opposite. You can see that these are going to have a lot of overlaps. Because we already kind of saw it up here. If I take the sine from the other point of view, so like tangent is 30, tangent of 60 is the overlap. Okay? So For sine and cosine, you don't really get that because they're both over h, but these are exactly the opposites of each other. So you get a little couple weird ones in there. So that we'll have memorized eventually. Okay, now we know a little bit about radians, so you have an assignment on that. And then we'll probably write out our little table here for what these values are. So we have 30, 60, 45. We'll write out 90 and 0, which we had kind of seen in some classes. But we didn't write it out for tangent yet, so we're going to do it for 0 degrees. Well, actually, I guess we could do it right here. So sine of 0 degrees is 0. And that's why, because you start your sine curve at 0, and then for cosine of 0, I guess degrees, we'll put it is 1. 0 degrees or 0 radians, doesn't really matter. That's because it starts at that value. Okay. So we'll stop there. That'll be the end of the video. You have a bunch of practice with doing this. Okay, and like I said, eventually I would like to have this table filled out with 30, 60, 90, or 30, 60, 45, and then pi over 6, pi over 3, and pi over 4. Same answers, 1/2, radical 3 over 2, 1 over radical 3. Okay, so we'll get to that in a second, and here are our reciprocal functions. Okay, so take a look at what we got to do. Those of you that took the AP and you're watching this later, I hope it went well. Those of you that are maybe studying for your AP instead of watching this video, good luck. Well, I guess you would watch it afterwards. And then the other guys, I'll probably see you on Tuesday. So have a good day. Good